Let's continue on with 6.4, Day 2. We're going to work on the next example in the notes packet. You'll notice I've made some changes to that example. Instead of y equals -2 times sine of 1/2 x minus pi over 2, I got rid of the 1/2 and I put -1 at the end. Would you please change your note packet to look like that? All right, from there, let's describe what's happening to the equation for the sine function. Right away, we notice that a is -2. That would mean that the amplitude is the absolute value of -2, which is +2. To describe the transformation or the translation for this function, the graph will stretch vertically. Also note that a is negative, so the graph will reflect over the x-axis. There we go. Notice the number in front of x is missing. So instead of the 1/2 from before, if it's gone, it just defaults to 1. That means the period stays 2 pi. There's no change horizontally, except for the fact that now x is in a parenthesis with that pi over 2. C equals -pi/2 means we're going to move left or right. So remember in the notes I said we're going to move in the opposite direction. Since c is negative, the graph is going to move to the right by c over b, or pi over 2 divided by 1, which is just pi over 2 units. Okay, so if c is negative, we're actually going to go to the right by that amount. Okay, so we'll take a look at that with our period for the function. The period of the function doesn't change, but our start value changes. So this is new for us. So instead of saying starting at 0, like we do with the parent function, we have to set the parenthesis equal to 0 and solve for x. So if we say x minus pi over 2 equals 0, and we add pi over 2 to get x by itself, that's a pi there we go. We're actually going to start our graph at pi over 2, since everything moves pi over 2 to the right. To figure out where the graph ends, remember we said set whatever the parenthesis is equal to 2 pi, and then work backwards to solve for x. Here to get x by itself, again, we're going to add pi over 2. But if I add pi over 2 to pi, I want to keep this a mixed or an improper fraction if possible. 2 pi would be the same as 2 over 1 pi. And if I want to get a common denominator, that'd be the same as 4 pi over 2. Now if you add them together, I don't know what I'm doing there. I'll just put that a star. That's fine. The graph will end at 4 pi over 2 plus pi over 2, which is 5 pi over 2. And we'll be able to make the values in between happen just by looking at the graph. This will be easy to set up all the values for the x in the transformation. Let's see, what else do we have? Oh, we have d equals -1. So anything with d would be a vertical shift up or down, and it's always the same amount. If d is negative, we're going to move down 1 unit. All right, everybody. I think we have all of our descriptions. Go ahead and sketch the graph of the parent function, y equals sine x. When you're done, press play, and we'll see what we can do for the graph of the transformation. All right, everyone. Hopefully your graph looks something like this. Now let's look at our new graph. If we're going to sketch the graph for y equals -2 times sine of x minus pi over 2 minus 1, we're going to affect both our input and our output. For the input values, instead of starting at 0, this is going to be the first time we've ever changed where we started the graph. We're going to be at pi over 2. And then we're going to end at 5 pi over 2. And we've got to figure out all the values in between. So we need three new input values. Over on the graph, if we take a look at pi over 2 being here and 5 pi over 2 here, do you see the middle is 3 pi over 2? It's halfway. So we can put that right in the middle. This one works out really nicely for us, where the divisions are just going to be spots that are already labeled on the graph for us. Halfway between pi over 2 and 3 pi over 2 is just 1 pi. And then halfway between 3 pi over 2 and 5 pi over 2 is 2 pi. So I'm going to go ahead and erase the graph right now with the red so that we can get our outputs. All right, that's better. For our output values, remember we have A and D that are going to affect where the outputs go. A is -2. That means we're going to take all of our original outputs, multiply them by -2, and then subtract 1. Looking at your original outputs, the first output is just plain 0. And if you multiply 0 by -2 and subtract 1, you get -1. The next output for our parent function was +1. But if we multiply +1 by -2, we get -2. And then if you subtract 1, you get -3. Back to 0, we'll move our graph back up to -1. When the output was originally -1, multiply that by -2, you get +2. -1 is +1. And then last but not least, when we're back at 0, we go over to drop down to -1. Let's see what this is going to look like on our graph. If I zoom out just a little bit to kind of get those points, just make it a little easier to work with. At pi over 2, we said the graph was going to be at -1. So we're going to start down here. At pi, we drop down to -3. At 3 pi over 2, we go back to -1. So we have a little bit of an overlap right there. At 2 pi, we go up to +1. And then at 5 pi over 2, where we said the new end is for our transformation, we go back to -1. So there are the 5 points for our translated parent function, just for one period of the cyclic graph. But we're going to connect the rest of the dots. The pattern then would be at the next dash mark at 3 pi, we'll drop back down to -3. At 7 pi over 2, we do that little overlap again right there at -1. And at 4 pi, we'll be up at +1. Over on the left, where we have our new start point, if I actually go to 0, we're going to move, the graph will just kind of continue on up to -1. At negative pi over 2, it'll be back down, or that was +1, sorry. Now we're at -1 at negative pi over 2. At negative pi, we drop down to -3. -3 pi over 2 goes back up to -1. At 2 pi, we're up to +1. -5 pi over 2, we do that overlap again at -1. I'm going to slide the graph over just a little bit to get that to fit. There we go. All right, we'll finish this up. At -3 pi, we're down to -3. -7 pi over 2. And then at 4 pi, we're back up to +1. If you look at the pattern for all those dots, do you see that it's going to be a continuous curve all the way through the graph? Go ahead and connect those dots, and then we'll finish up. With our graph, recognize that we translated it to the right. We reflected it over the x-axis, so the graph is kind of opposite. When it curves up for a regular sign, it actually curved down for the transformation. What else do? We moved everything down 1 unit, so the graph's a little bit lower than it should be with the parent function. And that was going to be the kind of all we're going to do for this video, and then tomorrow we'll finish that last example together in class.